Hey everyone, I've been working on this design here for quite a while now. It's actually on revision 38. Part of those revisions are due to adding components in, like screws and nuts. But the part itself has gone through at least 30 revisions, 8 of which are printed functional prototypes that I've gone through. I started with PLA, came out with 6 of them, and then I switched over to my final material, which is ASA, just because I need to withstand the high temperatures of my enclosure and being mounted to the linear rail directly next to a stepper motor. So I did a lot of modeling. I got the whole machine modeled up just so that I could get all my parts lined up correctly. And this is going to help me down the road with some other modifications. So I spent some time and actually accurately modeled the whole machine. That's really helped out quite a bit. Parts I have are essentially just mirrors of each other. I mirrored it across the axes on both sides, so there's just 2 parts. So all you really need to do is print 2 of each part file, and that covers all 4 sides of the linear rail. Importing your part into Cura or whatever slicer you choose to use. They come in upside down, so all you got to do is flip them back over so that the large flat side is on the bottom. You don't need any kind of supports printed. Just you can see some of the overhangs in the holes and a few little edge spots, but it prints really well with absolutely no supports, so much less post-processing time. And as far as other print settings, you can put a brim on if you're having problems with bed adhesion or warping. I recommend printing this out of ASA or ABS. So if you're having a hard time getting it to stick to the bed without warping, definitely think about adding a brim on there. For print settings here, I'm using a 0.6 millimeter nozzle. This helps increase the layer adhesion strength and speeds up the print time a little bit with my slow print speeds for this material. And I'm still using a 0.22 millimeter layer height, something that you would use with like your 0.4 millimeter nozzle, but that also helps increase that layer adhesion. I'm trying to print this pretty solid, so I'm using 7 walls and 13 top and bottom layers. This helps get me really solid areas around where this press fit bushing is going to be so that it doesn't move in the material at all. There is a little bit of room here for infill, but it doesn't really take up that much space. I'm using a 30% infill gyroid pattern. For material settings, I'm printing at 153 degrees Celsius nozzle temperature and an 85 degrees Celsius heated bed, and it is printed in an enclosure that I keep at about 40 degrees Celsius, so 104 degrees Fahrenheit. It's all being printed really slow. The overall print speed at 40, but the walls are at 20. Everything else is pretty slow as well. It takes a little bit longer, but with these high temperature materials, it really gives you a good result and reduces any kind of warping. I have other like settings like acceleration and jerk control, but this just depends on your machine and what you are able to do. Cooling again is very low because it's a high temperature material. I have mine set at 20%, but if you don't have a heated enclosure or just are having problems with warping, I would turn that down to 0. So I'll just go ahead and export this to my printer and get them going. I do use, you can see the leftovers of that glue. I use a Elmer's glue stick just for my bed, and it gives really good bed adhesion. But that part came out pretty flawlessly. There is a little bit of warping across the bottom here. that you can see. But up here it's flat. That's just, I think, because of this longer edge. There's more contraction along this long part, but the rest of the print is nice and flat. Okay, so for the first part of this install, we have our 3D print here. We start with our 2 aluminum bushings, and all you do to install these is just kind of put her in there, take your screwdriver to kind of get it in the hole, and then just press down on it. And I'm going to have to go back and forth a little bit. I tried to get it in a nice tight press fit in there so that there's as little material creep in the plastic as possible. Same thing on the other side. Get it in the hole there and press down. So they're not all the way set in yet, they're just flush with the walls. So what you have to do next is you put your screws in. These are also tight fit, so you might need to actually thread it through the plastic a little bit. This is probably the trickiest part of the process, is getting the aluminum bushing all the way tightened in. There we go, I got a good thread on that one. Get it just slightly snug right there. And then you're just gonna come in and grab with a pair of pliers. You can use a wrench to do this too, but I found the way I have it designed is you grab with a pair of pliers. Where the pliers come to a rest actually aligns perfectly with the slot. So let me see if I can show you this. And once it's like partially in, you can just let go with the pliers and you can just tighten it the rest of the way. And you don't need to super tighten this, just snug. And so now that aluminum bushing is pressed all the way into its hole, and that nut is now flush with the wall. So simply repeat for the other side. Now you will notice the nuts don't actually really press in. They're a little bit loose, so they will come out. I couldn't really get around that, but it is a tight enough fit that it will lock the nuts so you can tighten them. The reason being is the aluminum bushing that I'm using is actually slightly larger than the profile of the flat sides of the nut. So to get this a nice press fit, the nut needed to be slightly loose. But this is doing most of our work here. Okay, so now that we have our bolts installed for the wheel, we simply take our 2 M4 cap head screws. I'm using all Allens because they're really easy to tighten. And we can just kind of slot these in here, just kind of set them in place. Just enough so that they kind of hold. All the holes on here are pretty tight tolerances, so a lot of them you will probably need to thread into the plastic essentially. Let's get them just out the bottom so that they sit in place. Get it nice and tight. This one's a little hard to get really tight, so you're just gonna have to torque it as hard as you can with your fingers. You want to get it nice and snug because over time these ones can loosen up. We're just gonna take the long end there and apply a little extra pressure. Just want to make sure those are real tight. You might need to come back in eventually and retighten them as the plastic creeps a little. And then we take our wheel. I removed, on all mine, I removed the little center brass washers because they can get in the way sometimes. This is actually between those two bearings. And you can see it's kind of sticking out there on one side. So if it's not completely centered, you can always center it by just sticking something in there and pushing it centered. But the problem is sometimes what can happen is those screws will end up, they don't touch all the way in the middle when you tighten these screws in, but sometimes it'll kind of push on there. You can actually see on one of these some scoring marks. I don't know if that's really clear from where the bolt hit it, right there. It doesn't push on it very hard, but it's better just to not have it in there and not worry about trying to keep it centered. So now that this is tightened on there, simply just place our wheel, take our 4mm Allen, tighten our M5 cap screws. And the wheels hold pretty well in place, so the screws just go right in and kind of pull the wheel up. But there's a little gap in between the bottom, so you might need to wiggle it a little to get the bolts to start feeding through it. And then these ones don't really need to be that tight, just snug, snug. You can see I can turn the wheel here. So I might need to make an adjustment on here so that that is pushed up harder against the frame. But before you do that, make sure to install the opposing bottom side roller mount, because that will also apply pressure, which will push this one back in. So before you do anything and start adding shims underneath, if you add just a thin piece of paper underneath that far edge, take the wheel out, loosen up the screws, you kind of tilt it forward, you put a little shim piece of paper or whatever you have underneath the leading edge, underneath there, maybe about halfway under, or half an inch under there, and that'll actually lean the whole thing and push it up harder against the linear rail modules. So let me just repeat the same thing for the bottom, and then we'll see about our tolerances. So now that that one is on there, I can already feel these are a lot stiffer, especially the bottom one. Sometimes in between prints you can have a little discrepancy in between that wheel spacing depending on how your first layer goes down, and whether or not you got excessive warping on the part. So I am going to go ahead and now remove this top one. This is a pretty simple adjustment. You just back your screws out a bit, take the wheel out, just kind of push her out, come back in, loosen our connection points. So now you can see we have a little bit of movement here. So here I just have a thin piece of note card and then cut it after the fact. It's just right into that first bump on the bottom. Now we can go ahead, tighten up our unit again. that is nice and tight. That's just as tight as the bottom. Actually, it's slightly tighter. You can see this thing is rock solid now. It does not want to move. And the whole X-axis is no longer tilting and twisting on me. So simply repeat the same steps on the other side over there, and it will be good to go. I'm working on a brace for the actual print head unit, but I don't have that out yet. So, alright, now comes the testing phase. I've got a dial caliper set up here, and I'm going to try to read from the largest deflection point, which will be along the top here. So I'll read a plus and a minus deflection for that, as well as a plus and a minus deflection for the actual linear module itself. And I'll be running these tests with the wheels on and without the wheels on, just to get a comparative result to see how much this has increased the system rigidity, and I'll be throwing that into a spreadsheet. Alright, so here is the test with the wheels off. These are just sitting in here. The bottom wheel I took out completely on both sides. It's on 0. So you can see that motion right there. It's both the beam and the head twisting at that point. And that is quite a bit. And then the other direction here, definitely not as much in this direction. Alright, all my wheels are tightened back up nice and snug. This is actually the only one I needed to add these paper shims to. The other ones lined up real nice right off the print bed. But if there's any creep in the material, I can add shims later on. But it's pretty easy to test, you know, just to make sure those are nice and tight up on there. So let's go ahead and test this now that our wheels are on. And then the other direction. You can see that the movement is quite a bit less, and this axis doesn't move at all. Now it's just in here, so I have to create another device that will roll on these tracks, because I could shorten this bracket, but I think it'll be better to have it roll along out here, because that's the main axis of twisting, and it'll help support the other one as well. Alright, so here's my data in a spreadsheet here on Google. I entered the values here in thousandths for brace on and brace off, and then put it into a chart here. This is the best way to visualize it, I think. And you can see brace off, our play in the Y direction is pretty significant, especially in the tool head. The module doesn't look like it's moving that much, but if you look over here to when we apply our brace, that actually comes into play for the tool head as well, because it reduces our module play essentially to 0 and our tool head play very much lower. Calculated some percentages over here, and we can see in the tool head we have a 44% reduction in our negative direction and a 57.6% in the positive direction, and our module is 75 and 90. So I think that's a pretty good result, and I'm happy with that, so I'm going to leave the design as it is. I will continue working on designs to brace the tool head even more, so that we can hopefully get these bars down to the same as the module. These design files are now available on my Thingiverse page for free download, and hopefully you can get the same results as me. So if you have any questions, leave them in the comments, and thanks for watching.